Hey everyone, welcome back to our YouTube channel Concepts Decoded. Today we are starting with another topic called support vector. So, talking about it's an algorithm which is used to create a best line or a decision boundary to differentiate between classes. So, it works best when the data set is small and complex. Just like logistic regression, here also we try to find a hyperplane, but logistic regression is a probabilistic approach, whereas support vector machine is based on statistical approach. So what happens in SVM? It helps us find the optimal way to separate different classes by identifying support vectors. So what are these support vectors? Support vectors are the data points that are closest to the decision boundary. Let's understand it by a simple example. So let's imagine there is a garden in which there are sunflowers and roses. So, SVM is like a clever gardener who places a fence in the garden right in the middle. The flowers nearest to the fence are like special helpers guiding gardener where to put the fence. So, in this way, when a new flower blooms, the gardener can see which side of the fence it is and quickly know if it's a sunflower or a rose. So, this was the brief about what is support vector machine. Now, let's have a look how to write a code for it. So, first step is always importing libraries. Now we will upload our dataset. Copy the path. Now we'll split our dataset. Printing our data. Now we will do the feature scaling from. Now we will train our SVM model on the training set from which we will do this step SVM import. Now we will predict a new result. And we will predict now the test set results. Yped. Now we will make a confusion matrix. So we have the accuracy 9.30.93 and we have the confusion matrix. Now we will do a visualization for, first we will do for training set and then we will do for test set. We have visualized the result for the training set. We will do the same for the test set. So Okay, so we have the visualization graph of the training test set also. Now we will check the accuracy of the model, for which we will define a function model which will have two parameters, xtrain and ytrain. From sklearn, we have the accuracy of the SVM. We have the accuracy 0.9 and the required confusion matrix. Now we will make predictions. Model 0 means that we are using the first element of the model. We have ty test. Now we will import the ROC AOC curve. Zero dot matrix. Now we will plot the required curve, def plot ROC curve. We will have two parameters, FPR, TPR for x-axis and y-axis respectively. Give a line style will be dotted. False positive rate and y-axis is true positive rate. Now the probability. Yeah. Now we will compute the ROC ASC score and we will predict the probability. ROC ASC score. Print. Now we will compute the ROC curve, which will return us the false positive rate, true positive rate, and the threshold values. And lastly, we will plot our curve. So here is the ROC curve, and we have successfully implemented our SVM code. Till then, subscribe, like, and share our video, and stay curious and keep learning.